In this video, we're going to talk about the three main categories of radioactivity that we have in the nuclear chemistry unit, as well as the two main types of reactions, as well as half-life. So the three main types of radioactivity are alpha, beta, and gamma. So alpha decay is the heaviest of these, and it's the least penetrating. It consists of 2 protons and 2 neutrons, and it has a positive charge. So it's essentially a helium nucleus. So atoms that are radioactive will just spontaneously give off these particles and then transmutate into a new element. So uranium-238, when it gives off an alpha particle, will then become thorium. Notice that the mass number, which is number of protons and neutrons combined, goes down by 4, and our atomic number goes down by 2. So alpha decay results in a nucleus that is smaller at the end. Beta decay is basically an electron ejected from the nucleus. So essentially what happens is a neutron loses the negative part of itself and becomes a proton. So if uranium-238, that same atom, underwent beta decay, it would then become neptunium. Notice that the mass number doesn't change, but the atomic number increases by 1. Notice that in any of these reactions, the top numbers are the same on both sides of the arrow, and the bottom numbers are the same on both sides of the arrow. So you could have looked at this and said, what would be left? Well, if this side's 92, what plus -1 gives you 92? That would be 93. In gamma decay, I wrote out a reaction, but really it doesn't usually happen by itself. It's high energy radiation. It's just the highest form of electromagnetic radiation. And it typically accompanies the other types of decay as well as fission and fusion reactions. So fusion reactions are when 2 things fuse together to become one. So 2 smaller nuclei come together to form a larger one, such as hydrogen fusing to another hydrogen to form the larger element helium. Again, notice that my atomic numbers add up to be the same thing on both sides. Fission is the exact opposite of fusion. So fusion, 2 things come together to make one. In fission, one bigger thing breaks apart into medium-sized chunks. And typically, that happens with things like uranium, that's what's used in nuclear power plants as well as bombs, where you have a nucleus that becomes unstable when it's struck by a neutron, and it splits into these 2 medium-sized pieces. Now, this fission reaction we show you right here is kind of important because it results in something called a chain reaction, where some of the products are also reactants. So if these 3 neutrons are produced, it can then start 3 more of these reactions. So chain reaction, it can keep going, and if nothing stops it, then it's going to be boom. And then the last thing we looked at was half-life, which is the amount of time it takes for half of a radioactive sample to decay. So if you have element Z here, which has a half-life of 50 years, and I asked you, what percentage will remain after 150 years? Well, after 50 years go by, you'd have half your original sample. And after another 50 years go by, you'd have half of that. And then after another 50 years went by, so now you're at a total of 150 years, you would have 12.5% remaining. So you can see that this keeps getting cut in half. So essentially with any problem you're given on this, you just figure out how many half-lives go by, and then either do this or the exact opposite process.